Okay, this is Robbie the Robot, probably take 20, but this is where I'm at. This is the base of the Sharp Intellos UAVG drone. I've taken all the electronics and case off down to just the base that has the motors, the battery bay, that's it. And what I've got here, 2 rubber drive tires that came with it, and the 2 caster tires on the other side there. Front, back, doesn't really matter. But these tires here can roll side to side as well as front and back, so it steers like a tank. This is the drive wheel. It's belt driven to that wheel, so they turn the same direction, and it turns like a tank, but it turns a lot smoother on a dime because those wheels can slide side to side just as easily as they go forward and backward. So with that said, the Stoba battery, which you see 2 of them back there, those are 48 volt, 20 amp hour. They have a BMS built in, which is really nice. It protects me from screwing up, but it's picky. When you first turn it on, and it's got a BMS activate pin on it that I've hooked to these 2 wires right here, and that'll turn the BMS on and allow it to feed the full current to the battery. Otherwise, it's dead, as you can see. Then I've got, out of the battery, 2 $13 48 volt 400 watt ESCs that are controllable by a pulse width modulated signal. So the Arduino up there, which is in the StemTerra lab board, can feed it, and a 0 through 255, there's my speeds. And these particular speed controllers have Hall effect sensors, they're required. And this particular unit has Hall effect sensors rather than feedback. So what I've got here are 3 pins. I got a ground, I got the pulse width modulated input, and I've got a direction pin. And that's fed from both boxes to the Arduino. So if we come up to the Arduino, I got a couple of potentiometers. These are 5Ks, and they're going into 2 analog input pins, so I can read them, and I get a value between 0 and 1023. The PWM, of course, wants an output between 0 and 255. So what I do is I divide it by a whole lot, and what that does is take some of the jitteriness out of it, and then it gives me a value of 0 to 16 or 15, and then I subtract 8 from that, so I get both a negative value and a positive value. And the reason I do this is to allow me to pick the direction pins. So these potentiometers are centered, so if I turn it forward, I should have 8 values forward and 7 values reverse, and then 0 is all stop. All of that is great, and we're going to hope that works. But this filter capacitor on both my ESCs are there to keep the input power nice and clean. The problem is when you first apply DC to those filter capacitors, and they'll be in the 5 volt regulator that'll eventually power the Arduino, and a few other regulators to power some other fun stuff. All of those have filter capacitors that tell the battery management circuit, the BMC that's built into those batteries over there, tells it there's a short circuit, and as soon as you enable it, it shuts right on down. And you can see that if I allow the BMC to be perfectly in line. So right now I'm applying power direct, and you can watch, look at the power come on. I just connected. Yep, see that little blip of red, and that's it. No power, because it detects a short circuit. So I've got to have a pre-charge, which means I've got to have a little bit of load in line with all the goodies I've plugged in, and that's where this giant 4 ohm resistor, big huge ceramic resistor, it happens to have a thermal probe plugged into it, and I'll hook that up later so I can actually read how hot it's getting. But to be honest, I only need it in line with the batteries for all of a second, because it's only 4 ohms. It charges these caps up pretty damn fast. So I need to temporarily have this in circuit. So I've got a switch down here, and eventually this will be a relay controlled by the Arduino. And if I turn this switch off, now the resistor is in line with the battery. And then what I do when I flip this switch is I short out the resistor so it's just straight on through. And you'll see what happens. So I'm going to take these two wires here and I'm going to connect them, and I'll let you know when. It takes a few seconds for the BMS to decide to turn it on. Okay, they're on. Power, and flip it. Now the power stays on. See, I only needed it for just a quick second there to give me full power. So now both my ESCs are up and running, and my Arduino, hopefully, if I grab the toggle on the right here, and I'm going to move it this direction, away from 0. Okay? The disadvantage to this, and let's assume I'm actually riding this thing for fun, and eventually I will be, is that it goes in steps of 8. So there you see it kick in the next step, 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 and now we're at full power. So I got 8 steps forward, and if I zip this back to 0 and just keep turning, the direction pin flips around and runs it backwards, but I only got 7 increments that way. So it goes a little slower in reverse, but I can sit there, and because I have to go through 0 before I can get to forward or reverse, that gives the motors time to bring the wheels down to a slow crawl before the direction pin flips it. Because if you're running at full speed, and I have tried this, and you accidentally have the direction wire come off, causing it to go the other direction, it shuts everything down. This brings the motor to a dead stop. Why? It's a 400 watt DC brushless motor at 48 volts. And it's going through a 40-to-1 gear reduction before it goes 90 degrees out to the axle, which means that the wheels have a shit ton more mechanical advantage on that motor than the battery does. So yeah, it's not happy, and it sounds awful. So we won't do that. And so now with this other potential, now just imagine on these potentiometers, I got little levers, and I got tank steering, because now I can bring this side forward, and I get the same increments, and this side backwards, and I get the same increments. So now I've got an Arduino controlled robot, and he has control over the direction and the speed of both sets of motors, whatever code I want to put on it. Right now it's just directly feeding through an analog circuit from a potentiometer. Could be anything. I could write a program for him to go so far forward and then turn and whatever. So that's the next goal, is to eventually get some code on him and get a little RF module on there and have a little base station with a camera and whatnot, so we can go run around the yard autonomously, and I can control him from the comfort of my garage or whatever. So that's the basic electronics. I've got tomorrow coming the TTL high voltage relay. It's supposed to be able to take 50 amps, and it's going to replace that switch. And basically what's going to happen is the Arduino will be powered by this whole mess. So I'll come over and I'll hit the on button, which will close these two wires right here like I've got twisted, which will activate the BMS. The BMS will allow the battery to kick on about 3 seconds later. And as soon as it does, it'll power this 5-volt inverter, which will power the Arduino. And then one of the very first commands the Arduino does is bypass this massive resistor. So he'll only be on for a second, maybe 2, before the Arduino shuts him back off. Cool thing is, now the Arduino has control of killing the BMS. So should it detect a problem with, any number of sensors I might put on here, it has the ability to kill the battery, which I find maybe kind of useful. I'll probably wind up using more than one Arduino and maybe a Raspberry Pi or 2, all in all. But I think these batteries, which are very nice, they're not great for, scooters and whatnot, because they don't deliver, the 50 amps that straight LiPo does. This BMS does dither it quite a bit, but these things last longer and they're shelf stable. If you want to look it up, that's what the Stoba STOBA technology is. It's an additive to lipo, or light, in this case, lipo batteries. No, it's not a polymer, it's LiFo. And it makes it more shelf stable. It also guarantees longer life. But for a robot that doesn't go that fast anyway, it's perfect. And it's the batteries that came with the robot. So I might as well use them. All right, stay tuned for my next episode when, if I can, I'll have all this neatened up and I'm going to try writing it because I really want to.